Arc fault circuit interrupters, or AFCIs, are designed to protect against electrical fires caused by arc faults. However, they can sometimes trip unnecessarily, a phenomenon known as nuisance tripping. Several organizations and manufacturers have compiled information on common loads that may cause these nuisance trips. The Electrical Contractors Association of the National Capital Area, or ECA-NCA, offers a document titled Nuisance Tripping of Arc Fault Circuit Interrupters. This resource identifies inductive loads such as motors and transformers, capacitive loads such as fluorescent lights and surge protectors, and nonlinear loads like LED lights and dimmers as potential causes of nuisance tripping. Schneider Electric provides a white paper analyzing arc fault circuit interrupter technology. This paper discusses the reasons behind nuisance tripping and presents a table of typical loads that can trigger it, including vacuum cleaners, refrigerators, air conditioners, and microwave ovens. Eaton offers an application note that helps in understanding nuisance tripping of arc fault circuit interrupters. It gives a broad overview of nuisance tripping and includes examples of loads that may cause it, such as lighting fixtures with electronic ballasts, electric motors with pulse width modulation or PWM drives, and variable frequency drives, or VFDs. Other important resources include the National Electrical Code, or NEC. Section 210.12. The outlines the requirements for AFCIs and includes a note stating that loads fastened through sheet metal with self-tapping screws can lead to nuisance tripping. Underwriters Laboratories, UL, also provides relevant information. UL Standard 943. It covers AFCIs and features a section on nuisance tripping. UL also publishes a document specifically titled Nuisance Tripping of Arc Fault Circuit Interrupters, offering further details on the subject. It's important to remember that the specific loads that can induce nuisance tripping can vary based on the AFCI's brand and model. It is always best to consult the manufacturer's specifications for a particular AFCI to identify potential problem loads. The common loads that can cause nuisance tripping are inductive loads. Inductive loads are electrical loads that store energy in a magnetic field when current flows through them. Examples include motors, transformers, and inductors. When an inductive load is switched on or off, the magnetic field collapses, generating a voltage spike. This voltage spike can sometimes be misinterpreted by the AFCI as an arc fault, causing it to trip. Capacitive loads are electrical loads that store energy in an electric field when voltage is applied to them. Examples include capacitors, fluorescent lights, and surge protectors. When a capacitive load is switched on, it draws a large inrush current. This inrush current can sometimes be misinterpreted by the AFCI as an arc fault, causing it to trip. Nonlinear loads are electrical loads that draw current in a non-sinusoidal waveform. Examples include LED lights, dimmers, and electronic devices. Nonlinear loads generate harmonic currents, which are currents with frequencies that are multiples of the fundamental frequency. These harmonic currents can sometimes be misinterpreted by the AFCI as an arc fault, causing it to trip. In addition to the loads mentioned above, other factors can also contribute to nuisance tripping of AFCIs. These factors include poor wiring, loose connections, and electromagnetic interference. To troubleshoot nuisance tripping, it is important to first identify the loads that are causing the problem. This can be done by systematically disconnecting loads one at a time until the tripping stops. Once the problematic loads have been identified, there are several things that can be done to reduce the likelihood of nuisance tripping. These include using AFCIs that are specifically designed to be less sensitive to nuisance tripping, using line filters to reduce harmonic currents, improving wiring and connections, and shielding electrical circuits from electromagnetic interference. AFCIs are required in many locations throughout a residence according to the National Electrical Code. The 2023 NEC in Section 210.12 states that dwelling units shall have AFCIs installed to protect branch circuits supplying outlets or devices installed in kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms or areas. Arc fault protection devices have evolved over the years, and while they offer increased protection against unwanted arcing faults which could lead to fire, these devices are not without their issues. One of the most prevalent issues with AFCIs is the problem of nuisance tripping. Nuisance tripping refers to the unintentional or unwanted activation of the AFCI circuit breaker, which interrupts the electrical current even though there is no actual arc fault present. This can be frustrating and inconvenient, causing disruptions in power supply and potentially leading to unnecessary troubleshooting efforts. There are several reasons why AFCIs may experience nuisance tripping. One common cause is the presence of normal electrical activity that mimics the characteristics of an arc fault. For example, certain types of appliances or electronic devices can generate electrical noise or transient voltages that the AFCI may misinterpret as an arc. These devices may include older appliances with worn-out motors, fluorescent lights with failing ballasts, or electronic devices with faulty power supplies. Another factor that can contribute to nuisance tripping is poor wiring or electrical connections. Loose connections, damaged wires, or improper grounding can create electrical disturbances that trigger the AFCI. In some cases, external factors such as electromagnetic interference from nearby electrical equipment or power surges can also cause nuisance tripping. To minimize nuisance tripping, several strategies can be employed. One approach is to ensure that the electrical system is properly wired and maintained. This includes checking for loose connections, repairing any damaged wires, and ensuring that all electrical components are properly grounded. It may also be helpful to use high-quality electrical devices and appliances that are less likely to generate electrical noise or transient voltages. Another strategy is to use AFCIs that are specifically designed to be more resistant to nuisance tripping. These AFCIs typically incorporate advanced filtering and detection algorithms that can differentiate between genuine arc faults and normal electrical activity. Some AFCIs also offer adjustable sensitivity settings that allow electricians to fine-tune the device's response to electrical disturbances. In addition to these measures, it is important to educate homeowners and occupants about the potential causes of nuisance tripping and how to respond to it. This may include providing information on the types of appliances or devices that are known to cause problems, as well as instructions on how to reset the AFCI after it has tripped. By taking these steps, it is possible to reduce the incidence of nuisance tripping and ensure that AFCIs provide reliable protection against arc faults without causing unnecessary disruptions in power supply. Firstly, inductive loads can cause nuisance tripping. Motors, transformers, and other inductive devices store energy in a magnetic field when current flows through them. When the current is interrupted, the magnetic field collapses, generating a voltage spike that can be misinterpreted as an arc fault. Secondly, capacitive loads can cause nuisance tripping. Capacitors, fluorescent lights, and other capacitive devices store energy in an electric field when voltage is applied to them. When the voltage is suddenly changed, the capacitor discharges, generating a current surge that can be misinterpreted as an arc fault. Thirdly, nonlinear loads can cause nuisance tripping. Electronic devices, LED lighting, and other nonlinear loads draw current in short, irregular pulses. These pulses can generate high-frequency noise that can be misinterpreted as an arc fault. In addition to the type of load, other factors can also contribute to nuisance tripping. These factors include loose connections, damaged wiring, and electromagnetic interference. When troubleshooting nuisance tripping, it is important to consider all of these factors. A systematic approach can help identify the cause of the problem and implement the appropriate solution. Here are some steps you can take to troubleshoot nuisance tripping. 1. Identify the circuit that is tripping. This can be done by looking at the breaker panel and noting which breaker is tripped. 2. Identify the loads that are connected to the circuit. This can be done by looking at the outlets and switches that are served by the circuit. 3. Disconnect all of the loads from the circuit. This can be done by unplugging appliances and turning off switches. 4. Reset the AFCI breaker. If the breaker trips again, there is a problem with the wiring in the circuit. If the breaker does not trip, proceed to step 5. 5. Reconnect the loads to the circuit one at a time. After each load is reconnected, reset the AFCI breaker. If the breaker trips, the load that was just reconnected is the cause of the nuisance tripping. 6. Once you have identified the load that is causing the nuisance tripping, you can take steps to reduce the likelihood of it tripping again. These steps may include replacing the load with a different model, using a line filter to reduce noise, or improving the wiring in the circuit. In some cases, it may be necessary to replace the AFCI breaker with a different model. There are several different types of AFCI breakers available, and some are more resistant to nuisance tripping than others. If you are having trouble with nuisance tripping, it is important to consult with a qualified electrician. An electrician can help you identify the cause of the problem and implement the appropriate solution. Remember that AFCIs are designed to protect against electrical fires. It is important to take nuisance tripping seriously and to address the problem as soon as possible. The NEC requires arc fault circuit interrupter protection to protect dwelling unit branch circuits that supply outlets and devices installed in various rooms. This requirement aims to enhance fire safety by detecting and interrupting dangerous arc faults that could potentially ignite surrounding materials. The specific areas where AFCI protection is mandated typically include, but are not limited to, bedrooms, living rooms, family rooms, dining rooms, and kitchens. This comprehensive coverage ensures that common living spaces, where electrical hazards are more likely to occur, are adequately safeguarded against arc fault-related fires. The NEC defines an arc fault as an unintentional electrical discharge that occurs between two or more conductors or between a conductor and ground. These faults can arise due to damaged wiring, loose connections, or insulation breakdown. Arc faults generate intense heat, which can ignite nearby flammable materials, leading to fires. AFCI devices are specifically designed to detect the unique characteristics of arc faults, such as the erratic current flow and high-frequency electrical noise they produce. When an AFCI detects an arc fault, it quickly interrupts the circuit, cutting off the power supply and preventing the fault from escalating into a fire. The installation of AFCI protection in dwelling units has significantly reduced the risk of electrical fires. By proactively detecting and mitigating arc faults, these devices provide an essential layer of protection for occupants and their property. AFCI technology has undergone continuous development, leading to improved detection capabilities and reduced nuisance tripping. Nuisance tripping, which refers to the unintentional activation of the AFCI device due to normal electrical events, can be a source of frustration for homeowners. However, advancements in AFCI design have minimized this issue, making these devices more reliable and user-friendly. In addition to the NEC requirements, local jurisdictions may have their own regulations regarding AFCI protection. It is essential to consult with local building codes and electrical inspectors to ensure compliance with all applicable requirements. Understanding and adhering to these regulations is crucial for ensuring the safety of electrical installations and preventing electrical fires. AFCIs should be installed by a qualified electrician who is familiar with the NEC and local codes. Proper installation is critical for ensuring that the AFCI device functions correctly and provides effective protection against arc faults. Regular testing of AFCIs is also recommended to verify their functionality. This can be done by pressing the test button on the device, which simulates an arc fault and should cause the AFCI to trip. If the AFCI fails to trip during the test, it should be replaced immediately. Arc faults can occur in various locations throughout a building's electrical system, including wiring, receptacles, and appliances. Damaged or deteriorated wiring is a common cause of arc faults. Over time, the insulation on electrical wires can become brittle and crack, exposing the bare conductors. This can lead to arc faults when the conductors come into contact with each other or with grounded surfaces. Loose connections at receptacles and other electrical devices can also create arc faults. When connections are not properly tightened, they can generate heat and resistance, leading to arcing. Overloaded circuits can also contribute to arc faults. When a circuit is overloaded, the wires can overheat, causing the insulation to break down and creating a pathway for arcing. Regular inspections of electrical systems can help identify and address potential arc fault hazards before they cause a fire. These inspections should be performed by a qualified electrician who can identify signs of damaged wiring, loose connections, and overloaded circuits. Replacing outdated or damaged electrical components can significantly reduce the risk of arc faults. This includes replacing old wiring, receptacles, and circuit breakers. Ensuring that electrical circuits are not overloaded is also crucial for preventing arc faults. This can be achieved by distributing electrical loads evenly across multiple circuits and avoiding the use of extension cords as a permanent wiring solution. Educating occupants about the importance of electrical safety and arc fault prevention can also help reduce the risk of electrical fires. This includes teaching them how to identify potential hazards, such as frayed cords and loose connections, and how to respond to electrical emergencies. The evolution of AFCI technology has led to the development of different types of AFCIs, each designed to address specific arc fault scenarios. Branch/feeder AFCIs provide protection for the entire branch circuit, while outlet branch circuit AFCIs offer protection only at the receptacle level. Combination AFCIs combine the features of both branch/feeder and outlet branch circuit AFCIs, providing comprehensive protection for the entire circuit. Dual-function AFCIs combine arc fault protection with ground fault protection, offering enhanced safety in areas where both types of faults are likely to occur. The selection of the appropriate type of AFCI depends on the specific application and the level of protection required. It is important to consult with a qualified electrician to determine the best type of AFCI for a particular installation. The installation of AFCIs is a critical step in ensuring electrical safety and preventing electrical fires. By proactively detecting and mitigating arc faults, these devices provide an essential layer of protection for occupants and their property. The National Electrical Code provides requirements for arc fault circuit interrupter protection to mitigate fire hazards. The code mandates that AFCIs be installed in specific locations within dwelling units to protect branch circuits supplying those areas. These locations typically include bedrooms, living rooms, family rooms, and other similar living spaces. The purpose of AFCI protection is to detect and interrupt arc faults, which are dangerous electrical discharges that can ignite surrounding materials and cause fires. Arc faults often occur due to damaged or deteriorated wiring, loose connections, or insulation breakdown. AFCIs are designed to recognize the unique characteristics of arc faults, such as the erratic current flow and high-frequency electrical noise they produce. When an AFCI detects an arc fault, it quickly trips the circuit, cutting off the power supply and preventing the fault from escalating into a fire. The National Electrical Code specifies the types of circuits that require AFCI protection to ensure comprehensive fire safety. These circuits typically include those that supply lighting, receptacles, and other electrical devices in the designated living spaces. The NEC also outlines the performance requirements for AFCIs to ensure their effectiveness in detecting and interrupting arc faults. These requirements include specifications for trip time, sensitivity, and immunity to nuisance tripping. Nuisance tripping can occur when AFCIs mistakenly detect normal electrical events as arc faults, causing them to trip unnecessarily. To minimize nuisance tripping, AFCIs are designed with advanced filtering and detection algorithms that can differentiate between genuine arc faults and normal electrical activity. In addition to the NEC requirements, local jurisdictions may have their own regulations regarding AFCI protection. It is essential to consult with local building codes and electrical inspectors to ensure compliance with all applicable requirements. Proper installation of AFCIs is crucial for ensuring their effectiveness in preventing electrical fires. AFCIs should be installed by a qualified electrician who is familiar with the NEC and local codes. Regular testing of AFCIs is also recommended to verify their functionality. This can be done by pressing the test button on the device, which simulates an arc fault and should cause the AFCI to trip.